Okay, we just took a complete module and talked about filtration versus air cleaning, all of the particles and the sizes and that. Now we're going to address germ control. Remember, outside air, Mother Nature takes care of germs by using ultraviolet C energy. So let's see how we can harness the energy and the power of the sun and use that in our indoor air environment.
So Steve, when we start to look at some of the different biologicals or germs, all these different things that we can call them, the first thing that we look at is some of the surface contaminants that we have. That's going to be like the mildews, the molds, the funguses. And we've all seen that in equipment when we open it up. Our air handlers draw, or the evaporator coil draws moisture out of the air, and by drawing that moisture out of the air, it creates this wet environment inside the cabinet, and we get these things that it's a perfect breeding ground and place for them to grow. But it's also those airborne contaminants. It's the things like the bacteria, the viruses, the different types of cold germs that we sneeze out. Every time you sneeze, you put millions of germ droplets into the air, and those things are so small. Remember we talked about particle size, right? And the smaller they are, gravity just has
smaller than that, yeah.
It has such a small effect. It doesn't really pull it out of the air. So these things just simply float around in our environments, and when we go walking from room to room, or they get carried through our HVAC systems, they get spread from room to room, and then as other people breathe these things in, we're able to contract those different types of diseases.
Well, there was an interesting study that was just done. I just read this about a week ago, and it said that when the people sneezed, they had a certain distance they thought it traveled. It's hundreds of feet further than they initially thought, but I don't know how they figured out the new testing. But they're saying it does.
Sure, it's pretty nasty.
Yeah, it does get into our HVAC systems now, and it gets moved around, which used to be speculation. We kind of knew it happened because it stays suspended in the air, but they really travel further than they thought. So we've got these little particles in the air, and they 2 million of them could fit on the head of a pin. So we've got really small particles that are floating around the air when people sneeze, and they get into these droplets, and they create other challenges. Viruses get spread around, different types of bacteria. So what do? Most people if you ask a typical homeowner, do you do anything to kill germs today? Or if you ask a question, do you believe germs exist? Everybody's going to say yes.
Yeah,
we're bombarded with ads and stuff about germs.
It's not a hypothetical. Everybody knows there's germs out there. I mean, you can walk through airports today and people have their little surgical masks on, and everybody's got their little bottle of Purell.
Well, they got them on the wall. You hit them on the wall.
Yeah, this is something that there's posters up everywhere during flu season. Wash your hands. That's the easiest way to spread germs is through contact. Things like that. So we all know they're out there. It's not a myth. The germs are everywhere.
Right. So since everybody knows they're everywhere, everybody's trying to kill them, whether it's some kind of lotion on our hands. But typically, when you try to kill it in the air, people try to disinfect your air, what they do is they get some type of spray bottle. So a spray can, they spray stuff in the air.
Disinfectant sprays, there's a lot of different brands out there today.
Those are designed, if you listen to the ad, it says kills 99.9% of germs how?
On contact.
On contact. It has to physically contact the germ. So if we take the end of the studio over there and it had ants in that, your red ant buddies, if they were crawling in the corner over there, and we sprayed Raid in this corner, are they going to die?
I don't think it's going to do much good.
No, it has to contact them. And it's the same thing with the invisible germs that we're trying to kill. The spray has to contact them. So let's logically think through this. You spray something in the air. If I had a can of, let's pick on Lysol. If I had Lysol and sprayed it like this in the air, it might kill to the end of our little table here. But it's not going to kill the rest of the room. You'd have to take a can and spray all over the house.
Well, you could get one of those 5-gallon pumps or whatever, stick it on your back and
like
pump it up.
Yeah, you could spray all over the house, but you got it. It has to make contact with it. So spraying stuff in the air not only logically doesn't make sense, it's not good. We're trying to keep chemicals out of the air. And what you're seeing on the screen now is some of the things that are in these bottles. There's ethanol, ethylenes, benzenes, formaldehydes, naphthalenes, paradichlorobenzene, all these zenes and stuff that are in the air that we're trying to keep out of the air and control with an air cleaner.
Can't even pronounce half those things. Yeah. I had a technician bring up the other day, he goes, isn't that some of the stuff that's found in radiator fluid? Antifreeze in your vehicle?
It is.
Yeah.
Yeah. So here's the stuff we're trying to control with air cleaners, trying to keep out of the air. And there's people promoting to keep your air cleaner, to disinfect, let's put a bunch of chemicals in the air. So that really doesn't make much sense to me. So these chemicals are found, like you said, in other things, the all-purpose cleaner, disinfectant sprays, hand soaps, automotive antifreeze is on there as well.
He brought it up before that came up there.
Yeah. So we got deodorizers, germicidals, adhesives, permanent pressed fabrics, all this stuff has the same chemical in it. And if we're going to take a can and spray more of it in the air, that's not a good idea.
And these chemicals can't be good for us. They've got to have some sort of side effects associated with them.
Carcinogenics.
The truth is that all chemicals do. They're synthetics, and they all have different side effects.
Well, we got allergic reactions, skin disease, kidney disease, malfunction it could cause. It's extremely toxic to children and adults as well, but more for children because they're down in the lower environments where we're spraying stuff in that. Nasal irritation, headaches, dizziness, all this is attributed to something that we're spraying in the air that's supposed to be a benefit to us.
Yes, is to try and kill germs or to try and kill mold in our bathrooms. Tilex is another good one. If anybody's ever sprayed Tilex before,
Great cleaner, by the way. Don't get me in trouble.
Oh yeah. No, it's an awesome cleaner. But if you read the back of it, it says to use it in a well ventilated area. Well, how many of our little bathrooms are well ventilated? They're typically.
Tilex is doing the right thing. They said we got a product that works, but it's going to create fumes that could be dangerous for you. So ventilate.
Yeah, and in most cases we're not doing that. But you spray that stuff in that small bathroom, and what does it do? It runs you out of there. You'll start choking. It could cause a blurriness and all sorts of nasty things. It's a tough chemical to spray. It works, but it's a tough one.
So why don't we take the energy and the power of the sun and do the same thing? That's what Mother Nature's doing outside. The UVC energy and the stuff these wavelengths that are coming out from the sun aren't causing us problems. They're a huge benefit to us. So if we had a way to disinfect your air 24 hours a day naturally without using any chemicals or sprays, wouldn't you be interested in that? And that's a great question to ask a homeowner.
Yeah, I think it's a fantastic question to ask a homeowner because as a parent with two small children, knowing that I don't want to spray a bunch of chemicals in my home if I don't have to, if I knew that there was a natural way of doing it, I'd be much more interested in learning what that natural way is versus having all those chemicals around.
Well, as a parent with 3 big children, I agree with you. Even though they don't live at home anymore, but we'd want to disinfect and do the best job that we could to disinfect the air and control the microorganisms.
Right, and there is a natural way that we can do it.
Right.
We know that the sun works as a germicidal. We get all different types of energy from the sun. We get things like microwaves and radio waves, and we get visible light rays. That's what allows us to see colors and things like that. But there's a type of energy that we get, which is called UVC energy, which we've mentioned earlier. And that UVC energy, which can be measured on this chart that you're now seeing, that chart is called the electromagnetic spectrum. It's just simply a measurement tool. It measures the types of energy that we get from the sun. And that measures the ultraviolet energy, the A, the V, the C, and it shows that germicidal is found specifically at 254 nanometers. It's the wavelength of energy.
It's actually got a wider range than that. The 254 is where it's at its peak efficiency or its peak performance. It gets a little bit lower and higher than that, but as you can see on the chart, from 380 and above, that's the visual light. Then it breaks down into UVA, UVB, and UVC. And UVC, like John was saying, is in that 254 range. Now, when we get even smaller than that, 185, it creates an oxidizing agent known as ozone. So then we'll talk about that in another module.
Well, that UVC energy, when we expose UVC light in an HVAC system, that's going to disrupt the DNA of microorganisms that pass by that UVC energy, and it's going to render those things harmless and incapable of reproducing.
Does that mean it kills them all?
It doesn't necessarily mean it kills them, but it's sterilizing them. What it's doing is it's breaking down their cellular structure. It keeps those things from being able to reproduce, and if they can't reproduce, think back to the bucket theory or the allergy analogy that we talked about. If I were to sneeze today, and I had some sort of flu, and I sneezed that out, and you were to breathe that in, would you get sick today?
Not immediately, no. There's an incubation period.
Yeah,
it takes a while.
You wouldn't feel the effects of it. That's because that germ would get in you. It would have to incubate. It would have to multiply and reproduce over and over.
Fill the bucket up.
Fill your bucket up.
Create histamine, the whole thing.
Then you'd start to feel the effects of whatever that was,
right.
Cold or virus, whatever that was. Well, if that germ had passed by UVC energy first and it had sterilized it, even though it's still a live organism, if it sterilized it and it can't reproduce, how is it going to affect you?
The end result's going to be the same.
Yep. With multiple passes, you can actually kill some of those germs, but in most cases, they're going to be sterilized. So with multiple passes, you're going to kill some of those germs, bacteria. You're going to deactivate the rest. And when it comes to surface, you can get a 99.9% surface kill where that UVC lamp is in direct contact with those germs for a long period of time.
And the reason that number's so high, and we can calculate it, is because that stuff's not moving.
Yeah.
So it's not moving. It's on a surface like on a coil or on the side of an air handler or in the ductwork. Since it's not moving, that radiation has all kinds of dwell time. So you can use low output lamps, But we're going to talk about surface kill and airborne kill.
So guys, UVC intensity is not a new technology. Obviously, we've been getting it from the sun forever, as long as it's been around. But as far as using it as a germicidal, UVC energy was first talked about by Westinghouse. And they've
In 1930s,
yeah,
way long time ago.
Yeah, they've been using it for a long time. I mean, and ever since then, they've been using it in areas like hospitals and laboratories. We've seen it used in daycares. There's a lot of schools that use UVC energy in their ventilation systems today. And more recently, probably residential applications. Now,
Not
Steve,
until the earliest night. And when I got going into air quality, it didn't exist yet. I was on the first design team that helped design the first ultraviolet energy applications for residential applications. We didn't design. We didn't invent anything. It's
Right,
been
right.
out since, like you said,
So,
since
so
1930s.
20 years ago, we never saw this in a residential application, but you come down to Florida today, you open up
Oh,
an air
my gosh.
handler, what are you going to find in there?
Yeah, most of them have a UV light.
Yeah, typically they've got some sort of a UVC system in there. And we know these things work. And there's a lot of great studies that have been done out there, but there's one I want to touch on that was reported in the Lancet Medical Journal a few years ago. It was also reported by CNN, USA Today. But what this group did was they put UVC in the ventilation of an office building up in Canada, and they performed what was called a double-blind, multiple crossover trial.
Which means they didn't know they were being tested, basically.
Exactly. So during the course of this test, which they ran for the duration of a year, they would turn the lamps off for 12 weeks at a time, and then turn the lamps on for 4 weeks at a time. And at the end of the year, they had some pretty amazing results out of that test. So, some of the things they found was that there was a 99% reduction of microbes in the ventilation system.
When the system was on.
Yeah, when the system was on, there were no microbes in there, 99%. So all of those colony-forming units or microbes, whatever they called them, it was able to destroy those things because of that UVC intensity.
So the UVC had surface kill.
Absolutely, and as this was a commercial building, this wasn't just one UVC lamp. This was multiple systems in the HVAC system in there. But the results were phenomenal. At the end of the test, they found that it reduced overall worker sickness by 20%.
Wow.
Now, just think about that. I mean, we hear about things on the news about lost worker sick days and employee sick days, things like that. If you can reduce overall worker sickness by 20% just by using UVC, that to me is an
That'd be
incredible
phenomenal.
number.
Yep, absolutely.
40% drop in breathing problems. So this wasn't with the use of additional air cleaners and oxidation systems. This was just with UVC energy. It was able to break down those microbes that cause some different respiratory types issues, as well as mucus problems. It reduced mucus issues by about 30% for the participants that were in that building. So to me, that's a pretty incredible test. And there's lots of them out there that can be found on the internet.
I want to point something out about that test, too, is here's another organization, the Lancet Journal, has no skin in the game.
Yeah, it's a medical group.
Right. They're not like, no, let's sell our UV light. Yeah, our UV light did this. They said, here's what UV light does.
Yeah.
Right. Rather than, trying to sell you something.
So, Steve, let's talk a little bit about how UV actually works. We know it kills stuff or it sterilizes things when it has a certain exposure to it, but how does it actually work?
Well, the cool thing about UV, I always say, is UV cannot not work. Does
I
that
like
make sense?
Yeah.
It is science. It's not like we have to guess if it's a filter or an air cleaner, even though we can prove that with all the studies we've done and everything. But UV is one of those things that it is what it is. If I lit a match right now and threw it on the table, it would burn something. The fire burns. It's science.
Mm-hmm.
UV cannot not work. So with that said, but remember we talked early on in some of the early modules about design versus technology.
Right.
So UVC in the right design will kill stuff on surfaces. In another design, it'll do surface kill and airborne kill, but you got to have enough dwell time. So if I took a light and I took a petri dish and put it on the floor here, and I took a 45 microwatt UV light and put it a couple feet away, went out and had a cup of coffee, come back 30 minutes later, test that petri dish, everything's gonna be dead, right? So
That's that surface kill that we
that's
talked
surface
about.
kill because it's stationary, it's not moving. Now if I take that same petri dish and I zing it by like a frisbee at 400 feet per minute, like it's going by through ductwork. Now we got the light in and doesn't have enough power to kill stuff as it's going by real fast.
So you've got a lack of dwell time. It doesn't have the same amount of time to shine on there to really truly have an effect on it.
Right. So to get the right kill or the right sterilization, because UV light, when stuff's airborne, doesn't kill a lot. This has to get anywhere from 2 to 6 inches from the lamp, depending on what power you're using, in order for it to die. Some microorganisms would have to land on it and have a picnic before it dies. But
Those mold spores.
Yeah, those damn mold spores. So, but the right stuff, the viruses and bacterias, they're easier to kill. Viruses are single cell microorganisms, very easy to kill. Bacteria a little bit harder. You start getting the multi-cell stuff, but you might need a higher microwatt. So, when you're looking at UV, the higher the microwatt output, the better the sterilization is going to be.
So it has to be designed correctly if it's going to have an effect on those certain types of organisms,
Right.
knowing that they're going to be airborne. Because there's really two applications at that point. We're talking about a surface application, and we're talking about an airborne application.
Right.
And with stationary surfaces, as you've already mentioned, we don't need the same microwatt intensity. Those stationary surfaces, they don't need to be bathed in that UVC light that's as powerful as it would if it's in the airstream. If we're going to control the contaminants in that airstream that are quickly moving through there, we have to have a lot more power so that it's designed correctly to affect those airborne bacteria, those airborne viruses and mold spores and all those things that are moving past
And
there.
airborne is just as important, if not more important, than the stuff that's on the surfaces. So, because if we have the right UV light and we can kill and control it before it ever gets to the coil, it can't multiply in the coil. Now there's UV companies that are great companies that don't use high output lights, but they don't talk about airborne kill either. It's put it above the coil, put it below the coil, wherever they do it where you want to kill stuff on surfaces, and it will do what they claim. The ones that drive me nuts are the ones that use low output lights, and they claim kills everything on kitchen tables,
Airborne sterile,
all over the kitchen and doorknobs, and it sends Pac-Man out in the air and all that kind of
that
stuff.
goes back to some of the myths and the misconceptions that we've talked about, and that truly is the importance of understanding the technology of how this stuff works. And that's why we use sometimes some analogies to explain that we can have the right technology, but it may have the wrong design to it. And there's one that you always use, which I've always thought was a great example. And to me, it really hits home about how these things, you can have that right technology, but without the right design, it's just not going to function properly. And so with that analogy that you always use, you're always talking about a match.
Right.
So if you were trying to create a certain type of heat technology, and you had a match, and you were to strike that match, and you were to hold your hand above it, would it be hot?
Right.
Right. So now, Steve, with that same match, and we know that it creates heat, if I were to try and walk around a cold house in wintertime with that match, could I warm that entire house up?
No, it's because it's a match, but one match is 1 BTU, and it's not, even though it's the right technology, it's heat, right?
Mm-hmm.
It's not enough heat to heat a whole home. From being in the business a long time, that we don't have 1 BTU systems.
Yeah,
We
tens
have
of thousands,
tens of thousands of
50,
BTUs.
60,000 BTUs, depending on the size of the home.
That's what it takes to heat. So even though lighting a match is the right technology, it's the wrong design. And that analogy applies to UV. Even though you might say, I have a UVC lamp, doesn't mean it's the right design. And back to Westinghouse, they did studies back in the 60s and 70s on what it takes to kill or control microorganisms as they're going by the light.
Yeah, so not just the surface stuff, but the airborne stuff, which is truly, that's the most important thing that we want to get to.
And they have formulas they work with, and we can put the formulas on the screen here. But the formulas are they're actually working models of what it takes to control a microorganism, how many lights it would take to do it while it's airborne coming by at 400 or 500 feet per minute. And what they found is the minimum, when you're looking at about 2.5, 3 ton unit, 800 to 1,200 CFM, and which translates into about 200-300 feet per minute, you need at least a 55 microwatt lamp. So our first designs back in the early 90s were 55 microwatts. But what we found out was when you put the light in the system, we would do measurements every month. And we noticed it was 55 the first month, then it was 53. Then
So it was a
50.
little trial and error on some of these first design systems.
Exactly. It started coming down, and after a year, it just dropped. So went back to the lighting engineers and said, hey, what's wrong with these lights? And that's what they do. That's the nature of the beast. They solarize inside, and they stop the UV ray from coming out. And it loses about 1.2% a month of its output, about 15% a year. So you're like, holy cow, we were putting, it works.
We thought we were doing the right thing.
It's like an old electronic air cleaner. It works for the first month, but doesn't work afterwards. So the next design, the next evolution, we started using 70 microwatts. You take 15% of 70, you got 57 at the end of the year.
Mm-hmm.
Then we stepped up the game a little bit more and put a film inside the glass to make it last longer. Now we got 2-year lamps instead of 9,000-hour 1-year lamps that everybody else is using in the market.
Well, does the lamp still solarize at that point?
Oh yeah, they all
No.
solarize, but it's nice to have. Now we have the it just whole lot solarizes slower, and we have the higher output lamp that we use 180 microwatt today, and we're going to get into in a minute here. And so at the end of the day, what you want for UV light to work is it to shine with as much intensity as it can inside the ductwork. So what you want, and it's best to have it on the return. You want to kill and control it before it ever gets there. But the reason most tell you to put it on the supply or above a coil is because they don't have a high enough intensity to do it anyway. So the 180 microwatt lamp is what we need in order to control microorganisms as they're airborne. Okay, just to go through the features of some of the high intensity lights that are out there, ours being a dynamic 401H, it has a 36 watt UVC bulb, a 16-inch bulb. That's not the microwatts. It has 180 microwatts. The wattage is the energy it's going to use. It's like people say, how much is it going to, how much energy does it use? It's like putting a 40-watt light.
Yeah, so if a homeowner asks, it's not very much.
No.
I mean, if you were to look at your electric bill with one on or one off, it's not going to make
Right.
hardly
And it's
any
not the
any
wattage that's
difference.
doing the work anyway. It's the micro wattage. So we have a 180 microwatt lamp. It's got a ballast in there, smart ballast. It knows if it's plugged into 120 or 110, 220, 240. So you don't have to have a switch or change a different
Yeah,
lamp.
so it's going to be able to
both.
detect whether it's going in an air handler or a gas furnace. You don't have to set the actual unit for it. It's going to
Right.
detect that if you wire it into the EAC terminal in the system.
Yep, and we talked about the special coating. Makes it last 2 years. It's got some things that other parts and pieces that come with it if you need them, like for a duct board, for example. Duct board's about that thick. If you put the light in, we don't want to cut any of the light off, so we got a duct board insert that goes in there. It'll be flush on the inside, and then you would mount it to that.
Yeah, recesses the lamp so it's bypassing all the duct board itself, and it allows a better adhesion to the duct board as well. If you just tried to mount the ballast on there, chances are it would get flimsy after a while. With the recess plate, it's going to keep it nice and tight, and it gives it a solid surface to mount that lamp on there.
Right, and then it's got an optional current sensor relay, which would turn it on and off with current, or you can wire it to the EAC terminal. See, our unit can handle on-off cycles. A lot of UV manufacturers say just leave it on all the time. Well, you know, if it's using UVC, it's not going to hurt it to leave it on all the time, but why not turn it off if it's don't have any airflow?
Yeah, this can be wired either way. You can wire this one hot if you prefer to do that, but keep in mind if it's on all the time, it's not killing any airborne germs if there's no airflow going past it. So you can wire it hot, or you can have it cycle with the furnace blower. And in most cases, guys just will wire it right into the EAC terminal that's available on your furnace. So that's not always available on our air handlers, but on furnaces, there's usually going to be one there.
Well, and another reason is, the reason we can cycle is here again because of the smart ballast. This smart ballast is potted ballast. We talked about potted and how the importance of that. And it also has a sensor in there that actually it's a slow start, I guess you'd call it. It starts the lamp slower so it doesn't stress the filament. You know, John, when does a light bulb burn out? When you flick it on,
Yeah,
right?
when you flip it on a bunch of different times.
Yeah, it's been on and off, you know, whatever it can take, hundreds of 200 times, 1,000 times. And then that one time you turn it on, you see a blue flash and it comes off. It breaks the filament. So same thing will happen with these unless you slow start them. So the ballast will slow start. I've even had technicians say, I've been installing UV lights for, 15 years and they just go on. You know, yours guys has this little flicker thing. Well, it is slow starting the ballast so it doesn't stress the filament out. So we can take the tens of thousands on-off cycles a year so it can last its 2 years. And the lasting of it, it'll stop producing UV energy before it burns out. So,
And homeowners will ask that because trust
Why
me,
you change it? It's still on.
Yeah, I've been asked that question before. You know, hey, I still see a blue glow coming from my system.
So it must be working.
Yeah, it must be working. Well, with that, so you mentioned the solarization process. If it's longer than a couple of year period with our lamp, in fact, about 85% in our industry are what they still call 1 year lamps or 9,000 hour lamps.
Right.
With the Dynamic, it's a 2 year lamp. After 2 years, though, that drop off in microwatt intensity is going to occur pretty quickly. So it's hard to say it's 2 years and a week or 2 years and 3 months.
Just get in the habit of changing them every 2 years.
2 years for
Right.
that homeowner. And that way it's going to work at its peak efficiency. And with doing that, there's a 2-year warranty on the lamp itself. And the most important part is there's a lifetime warranty on that ballast. Again, it's a potted electronic
It's
board in
bulletproof.
there.
Yeah.
It's a very bulletproof board. You can feel the weight and the heft of that when you're installing it. It's a fantastic unit. So it's going to have that lifetime warranty on there. So if anything's wrong with the unit, you just want to check and make sure that you've got the proper voltage going to it. If you have the proper voltage going to it and the lamps still aren't on, change the lamps out and try those. And if the ballast still doesn't come on, you've got a lifetime warranty on that.
And it's typically not the ballast. It's something else that's involved in the unit itself.
Yeah, typically it's going to be the lamps themselves. So
And just a couple precautions. I think hopefully all you know this, that you don't want to stare into these lights. You don't want to install them in an area where they might be shining out onto the carpet that it's installed like with a return right by on the floor there, because it will fade the carpets.
yeah, remember UV is a very intense, especially UVC. It's a very intense type of radiation.
Right. Can burn your eyes, can burn your skin. So make sure they're off if you're working on a unit. Don't use it as a utility light.
Yeah, it'll burn your eyes, guys. I've had technicians or I've known technicians that have had to go to the hospital because it feels like somebody threw a handful of sand in their eyes the night after they stared.
Never had it
Just
happen to me, but I've heard the explanation.
Yeah, I've heard it's pretty bad. So it's, just take some precautions with that. Make sure the power's off. And as Steve says, avoid certain plastics and wire coatings. Most manufacturers know and have UVC specific coatings put in their drain pans and things like that. But that still doesn't mean that you want the UV light shining on the control panel or the actual boards or the wires within that furnace or that air handler. So
If
just
there
take
is
some
an
precautions.
installation though where they can't put it anywhere except where it's going to shine on something you don't want it to shine on, we can have a shield.
Yeah.
We have a shield
Yep.
that you can shield it and shine it in one direction.
Even filters themselves, that's probably one of the big ones, is that UVC energy can destroy certain paper filters and even flex duct if it shines on the inside of the plastic of the flex duct, and that's where those shields come into play. And we have a module that talks specifically about the products and some of the accessories along with the shields and the recess plates that you'll be able to see.
Okay, that's it for ultraviolet energy and the germ control. Our next module, we're going to talk about oxidation and how to use UV light to accomplish that.